All right, here we got 3.12 notes, growth and decay, which is an application of differential equations. So our goal today is to interpret, create, and solve differential equations from growth and decay context, okay? So here is the video example. We're going to do this problem right here. It says the rate of change of y is proportional to y. Okay, so in this case, they don't give us any equation, but this right here is key to solving this. This is key to writing our differential equation. Okay, so it says the rate of change of y. What does that mean? The rate of change of y. That means the rate of change is dy d. Now there's a clue. You see how the two variables are x and y. So dy dx is the rate of change of y. Okay, and it says it is equal to proportional to y. So when we see proportional to y, what we do is we write it's a proportional constant k proportional to y. So we're going to say ky. Right? So proportional to y is that ky. So that's how you set up the equation using that statement. Okay. Now what's going to happen is we're going to need these two conditions, x equals 0, y equals 24, and x equals 2, y equals 38, to help us solve this differential equation. Okay, so let's do this. Our first step in every differential equation is to separate the variables. So the dy stays. I'm going to multiply by dx. So that goes away. And I'm also going to multiply by 1 over y to cancel this guy. Which leaves us with 1 over y dy is equal to k dx. We're all set. Let's take the integral. So integral of 1 over y is the natural log of y, which is equal to kx plus c. What we want to do to get rid of the natural log is we want to raise to the e power on both, which leaves us with just y is equal to e to the kx plus c. But remember, we can change that into e to the kx times e to the c using exponent properties, which leads us to e to the kx times, because e to the c, e to a constant is just another constant, and so it gives us c1 times e to the kx, which is equal to y, and there is our general equation. Okay, now notice here's the key. Notice that when we have our equation y is equal to e to the kx, our final equation ends up being y equals c1. What is going on here? When y is equal to c1 times e to the kx. Notice that there are two constants here. We have the c1, and then we have the k, right? And if you have two constants, you're going to need two conditions, okay? So we have a choice to plug in x equals 0, y equals 24, or x equals 2 and y equals 38. I'd recommend choosing the easier option. So probably this one is easier because we have a 0. So let's plug that in. So when we have 0, 24 as our condition, we end up getting 24 is equal to C1 times e to the k times 0, which is just 24 is equal to C1 times e to the 0. E to the 0 just is 1, so we know C1 is equal to 24. That's awesome. So we get y is equal to 24 times e to the kx. And why don't I rewrite that in red? Y is equal to 24 times e to the kx. Alright, so we're all set. Now we just gotta do our next condition. So if we're doing 2 comma 38, that should help us solve for k. So we have 38 is equal to 24 times e to the k times 2. So to solve this exponential function, let's divide by 24. So we have 38 over 24 is just 19 over 12 is equal to e to the 2k. How do you solve exponential functions? Well, we can turn it into a log function, or you can apply the log function to both. What's nice is the left side can stay the natural log of 19 over 12. But on the right side, we know that by the power rule, you can move the power to the front. So it becomes 2k natural log of e. And we know that natural log of e is just 1. I'm going to go back up here. So we know that the natural log of 19 over 12 is equal to 2k, and therefore k is equal to 1/2 natural log of 19 over 12. And we can actually figure out what that is if you'd like. So 0.5 natural log of 19 over 12 is equal to 0.2297. We want 3 decimals, so round it to 30. Okay. So let's see, are we done? It asks us what is the value of y when x is equal to 10. Okay. So I think we found our final equation. We know that y is equal to 24 e to the 0.230. Actually, why don't we use the natural log version? 1/2 ln of 19 over 12 kx. That's what we found is our equation, our particular solution, and we want to find the y value when x equals 10. So when x equals 10, y equals 24 e to the 1/2 natural log of 19 over 12 times 10. And we can leave it like that, and you would get perfect points for that, or we can evaluate this as well. 24 e to the 0.5 natural log 19 over 12 times 10 gives us 238.82. And there you go. So what you're going to do now is you are going to do group problems, and you're going to do the following problems 1, 2, 3, and 4 with your group, using this as a foundation. Okay, good luck everybody.